Hi guys, today we're going to be talking about text files with Python and how you can use this to access data in Python. So with a text file, you can store and retrieve text from a file. Now, on a file system, there are typically multiple kinds of files that we interact with, but primitively, there's two basic kinds, and we'll get to that in a minute. But text files are the kind of files that we use to store text and read text from these. And so these files are understood to be human readable in that if I open the file up in what we call a text editor, we should be able to read its contents just like we would if we were reading a book or anything else. Now, that doesn't mean that the file itself will be necessarily English or a language that we're used to, but in any case, what it will be is a file that, as a human, I can open it up and at least understand what it's trying to communicate by reading it in a program. So text files are very useful for storing and retrieving data, and we use them all the time. In fact, we've been using them to store all of our code because most of the time when you're doing code, it's stored in a text file of sorts. So let's go right over to a deck, and then let's talk about some of the things that are features of text files, and then we'll go over to Tony and we'll do a couple of examples of how you can send data to a disk and then read data off a disk using text files. So on our computer systems, we typically have two kinds of files. As I mentioned, we're going to be talking about text files today, but there's also another kind of file that's called a binary file. Now, a binary file is a file that has data that is stored in bits that if you were to open in a text editor, you wouldn't be able to understand it. An example of this might be something like an image. So if you were to take an image, such as a JPEG file or a PNG file, and open that in a text editor, it's going to have a bunch of encoding that you wouldn't be able to understand. You might be able to see something in there that you might recognize, but generally speaking, you're not going to be able to read these. A text file, on the other hand, is converse to that. If you were to open it up in a text editor, you should be able to read it without any problem. And these two types of files are generally what are going to be making up what we have on our computers. Pretty much any file on our system can be classified as either a text file or as a binary file. And generally speaking, that is going to hold true for not just files on your computer, but also files online as well. A text file is said, like I said to be human readable. You can open it in a text editor, and that's one way to test if you can have a text file or you're dealing with binary data, is just pop it open in a text editor. If it looks strange to you, probably not a text file, it's probably a binary file. And one thing that you have to worry about with binary files, not so much, but with text files, is the encoding on the file. And we'll look at this in just a second. I'm going to open up an example in a text editor, but the encoding is basically how the bits are stored on the disk or on whatever media that you're using to represent the text that's in the file. Now, different encodings will store files differently. Most of the time, files are stored in what we call UTF-8, which is a very common encoding that is pretty much used by most everything on the internet, but there are other encodings out there. And the encoding will determine how the bits are stored. So if you were to save a text file as one encoding, but try to open it as another, it would look like a binary file if you were to open it up. However, most of the time, given that we have kind of moved into the age of the internet, most people have kind of adopted the UTF-8 basis for all the encoding that they use for files on the internet. And it encapsulates a number of other encodings as well. It also encapsulates international characters as well as things like emojis and a number of other things. So it's a very broad category for representing data. I'm not going to get into the details of how it all works, but just understand that encoding is important whenever we're talking about files. And when you're reading those off of the internet, sometimes you might download a file that appears to be text data, but the encoding is off. And then if you were to open that in a text editor, it would be kind of strange looking. But if the encoding is UTF-8, usually it's going to work just fine. Now, another thing that we have to worry about with text files is line endings. Now, on a computer that is modern, that is pretty much anything made in the last 10 or 15 years, line ending is not as big a deal as it once was. However, certain kinds of operating systems have native line endings. So Windows does it one way, Linux and Unix does it another. And this can be a point of contention if you're dealing with some older applications and if you're dealing with command line type things inside of a computer. But it's probably not a big deal for most people because the text editor is going to be able to recognize the line ending and be able to infer what it is basically by just reading the text file. But I'm going to show you a text file and then I'm going to point out the encoding and the line ending to you just so you're aware of this. But for our purposes, probably not going to be a big deal because Python is going to follow the more Linux type of conventions where it's going to use the Linux type line endings. However, it will read files that use the line ending that's more native to Windows. And most of the time, that's not going to be a big deal, except when you're dealing with older applications that don't necessarily support another operating system's line endings. But just to make you aware of that, let's go over to a text editor and actually take a look at a text file, and then I'll point out some of these features to you. I'm here in a text editor called Notepad++, and this is a Notepad text editor that you can install on Windows and edit code in. I use this for a lot of coding. I don't typically do all my coding in something like Tony. I actually do a lot of coding in this app right here because it's just a pretty basic, or really not a basic, but it's a very good text editor for doing a lot of cool things with programming type techniques, and it does support parsing a Python file, which I have here. So my point of this is not to show you this particular Python file. You should recognize it from last week's lesson. However, I do want you to see what this is doing here. Notice it's a text file. It's a bunch of lines, and I open this up inside of my text editor here, but I created this file in Tony. So it is a text file. I can open it up in any text editor and should be able to read it. Now, this particular one is using UTF-8, as I mentioned. Notice down here in this bottom right corner, it shows me this UTF-8 right here. That's the encoding that I was talking about. And notice this right here says Windows CRLF. That is the line ending for this particular file. So that means that if I hit enter and put in a new line, it's actually putting in some characters that I can't see on the screen that are invisible characters, but it indicates the end of a line. Therefore, it'll what it calls wrapping the line, and it will start a new line at that point. And so I can remove that as well, but I can easily change this to something else. I'm going to do an EOL conversion to say Linux or Unix, and it's going to say line feed, and which is LF down here. And then if I wanted to change it to the Macintosh, like what Macintosh does, they use carriage return. So if you look at this one uses a carriage return line feed, Unix uses line feed, and Macintosh uses carriage return. So all of these are equally valid depending on the context you're dealing with and depending on the text editor you're using, which one it's going to use natively. But however, the point that I'm making here is that the end of the line marker for different operating systems is going to be different. So if you get a file that looks like it's all in one line, you can sometimes just go over to the EOL conversion and flip it to one or the other, and it will work well. But if you're taking a file from Windows and then moving it over to say a Mac and you're working in the CLI, sometimes it won't work because the EOL is off. So you need to take it to a Macintosh EOL or take it to a Unix EOL for a Linux-based machine or something along those lines. But that's the encoding and the line ending that I wanted to show you for this particular file. But this one I created on Windows box, so naturally I would expect it to have a Windows line ending, but the encoding is still UTF-8, which is again more of those universal encodings that you'll find across multiple machines, including Linux, Windows, and Macintosh machines. Another core concept when we talk about accessing files is understanding how a program accesses a file on the file system. Now, there's basically three modes of which a file can be accessed. One is read. So if I open a file as read, I'm basically just wanting to get the data out of that file. Now, if I open a file as read, it doesn't create what we call an exclusive lock on the file, which in some operating systems means that nothing else can write to that file or access that file while it's being used. Now, I'm not going to get into the details of all that, but basically, if you want to read a file, you need to open the file as read, and then you can get the text data out of that file. And there are two for writing data. There's the write, of course, which is the basic one that will allow you to create or override an existing file. Basically, it's going to take whatever you pass into the program, and it's going to either overwrite what's already there, or it's going to create a new file from the data that you use in the write. And then there is what we call append, and this is where we can take an existing file and add data to the bottom of it. So in a text file, we just basically want to create a new line in that file or something like that. Append is very useful. Now, when you use write is whenever you're A, creating a file, or B, you just want to overwrite everything in the file. And this has its time and place, and for many use cases, this is appropriate. And we'll talk about one next week whenever we're talking about object serialization. However, append is very useful for making something fast. And the reason why you want to use append is sometimes when you're writing with text files, you might end up with some rather large text files that have thousands and thousands or maybe even millions of lines in them. And you don't want to have to load all that data just to add one file, one line to that file. And so what you can do then is just do a quick append to a rather large text file without actually having to completely load that text file all the data append to a string and then write that all back to the disk. So that's an expensive operation. So appending is very useful for that time whenever you just want to quickly add data to a file to the end of that file. If you want to update something in the middle of the file, however, that's a completely different story. You would have to pretty much load the entire file, edit the data in memory, and then write it back to the disk as you write that file. Now, there are other ways to access files. I'm not going to get into the weeds on those. These are the three basic ways to access text files, and they're the ones that we're going to talk about today with Python, particularly dealing with text files. But there are other ones that allow us to open up a file, read it one line at a time without having to read everything, or something along those lines. The point I'm making here is that these are the three that we are going to be using, and these are the three that are supported by most operating systems at the operating system level as well. So let's go over to Python, and let's actually look at a slide first, and then we'll go over to Tony and we'll demonstrate how to use each one of these file modes to create a file, read a file, and then append a file. I want to look at a couple of basic examples of how you might read and write files in the slides. Then we'll go over and do a demo naturally in Tony. Now, this is the most basic way to read a file. It's actually really easy to do. So we just create a variable, call it f, and this can be anything. It doesn't have to be f. And this is what we're going to call a file pointer. And so basically, it's just a reference in memory that I can use to access a file. And so what I have here is the open command. Now, open allows me to open a text file. Now, when I open the text file, I need to specify what file I want to open. Now, this is a string, so you can pass in a string or you can hard code data right here as well. And since I am using a string right here, I can put in anything that is supported by the operating system's file names that are valid for the operating system that I'm working with. So if it doesn't work with that particular operating system, the character doesn't work, for instance, or the way that I'm mapping it out, then it won't open that file. It'll give you some kind of error. But point I'm making here is that you can pretty much name the file anything you want to. You just make sure that that file exists on your drive before you start trying to read it. And we'll look at how to do that too with try catches and things along those lines. And this is just the name of the file. And then if you needed the path, you could put in like the folder that it was in. So what the drive it's on, what folder it's in, and then ultimately what the name of the file is. This down here tells me what mode I'm going to be using. So if I use R, that means I'm doing a read. So if I was doing append, I'd use A. If I was using write, I would use W. So RWA gives me read, write, append, which are the three file modes that we're talking about today. And so once I have the file pointer, I have this handle right here. Sometimes it's called a file handle called F. I can then read from the file. So what I'm doing basically right here is I'm just going to read data out of the file, f.read, open close paren. And that's going to take the content of this file and then read it as a string. It's going to decode it. Basically, it's going to take that encoding that we have, decode it into text, and then it's going to assign that text as a string to my variable here, x. And then I'm just simply going to print the content of that back to the screen with x right there. So again, very easy to do for read. Writing is not too far removed from that. It looks very similar to what we just did. In this case, what we have here is another file pointer or file handle, same variable name, f, and I'm going to open a file right here, and same file name if I wanted to use that, my file.txt, and I'm going to use the file mode W. W tells me that I'm writing, so remember read, write, append, W is for write. So this is telling me that I want to create a file or completely overwrite a file if it exists. So if this exists and I specify W, it's going to take everything in that file, discard it, and write over it what I tell it to. However, if I wanted to append to that, I would use A. We'll look at an example of that in just a second. Here I'm taking a variable called X, assigning some string data to it. And here I'm taking my file handle, and then I'm just calling write with that variable. And then it's going to take that data in X and then write to that file handle right there. And then I'm going to call f.close, which is going to close out the file, and then it's going to be written to the disk, and I no longer can write data to it. Now, there are some other types of operations you can do with text files. Like I said, we're not going to get into those today. I just want you to understand that whenever you're dealing with text files, read, write, and append are your friend when you're doing some of these more primitive operations like we're doing. There's other ways to write one line at a time, as I mentioned, but I want you to understand the basics of file IO when we're talking about read, write, and append with these particular examples here, because this is going to be something that you can use in most any programming language, not necessarily just Python. So let's look at one more example, and then we'll go to Tony, and we'll take a look at how you can do some of this in code with Tony. Now, with this particular example, the only difference between this and the previous slide is that in this one, I'm using file mode A. And file mode A is basically an append operation. So what this is basically going to tell me to do is going to append the data in this file right here. So I have my text file right here, and I'm going to say open. But in this case, I'm going to do A against it. And then what this is going to do then is it's just going to take this data and append it to the bottom of the file. And so this is not going to do anything particularly trivial, new. It's just going to take the data, write it to the bottom of the file, and then close it out. And once it's done with that, instead of overwriting the file, it's just going to basically replace the data that's in the file. So let's go over to Tony and let's create some examples of how to do this. And we'll code this up, and it'll be fairly quick demos. But again, it'll give you then the idea of what we're trying to accomplish with reading and writing files. Okay, I'm here inside of Tony, and I have a new file right here that is for my write example. I'm going to start with writing data. So let's go start with a try block here. I'm just going to say try except, and that's just so I can handle my exceptions should something happen. And remember when I was talking about exceptions, it's always good to have that around file IO or any kind of IO, because it's possible most of the time when you're doing IO for something bad to happen. So I'm going to print something to the screen that says something bad happened. And that's just a good habit to get into when you're doing file IO. So let's go ahead and create a file here, file handle really, and I'm going to call it F. So F equals open, and I'm going to pass in a file name for the parameter. So my file.txt, and I'm going to set the mode to W. So that's just going to open up a file, and I'm going to say file.write, and I'm going to pass in some data. I haven't assigned X, so I'm going to get X as input, and I'm just going to say enter in some text right here, and that's just going to get me some text from the keyboard. Open my file, write the data, and then I'm going to do f.close. Now, remember when I talked about the line ending, that is the line ending for my program. For a Python application, the best way to do that is to add a \n, and this is an escape character. It basically says new line, and this is the one that is going to be used by Unix or Linux-based operating systems. And the reason why I'm using it here is because most of the time that's what's going to be supported by whatever operating system I'm using. It's going to work with Windows, it's going to work with Macintosh, it's going to work with Linux. And because Linux is kind of an open source operating system and Python is open source software, it's going to have more of an affinity for that particular line ending. You could use other ones if you wanted to, but this is probably going to be the best way to handle that. So let's go ahead and add the \n to our data right here so that we make sure that we're doing a Unix style line ending when we write our data. So let's go ahead and run this, and I'm going to say my name is Blaze. Run that, and let's go open up our file now. I should see it right here. There, sure enough, blaze.txt. And let's reload this file, and there is the data in my file. And notice that I have a blank line here because I ended the line with \n. So let's go ahead and let's put in the EOL conversion to this to make sure that it is Unix. That's what I intended it to be. But in any case, I'm getting a new line here because I put in \n. So if I run that program again, what I'm going to end up with is overwriting that file with new data. This is I am a developer, like that. And if I come back over here and reload this, notice that it completely overwrote the data that was in my file. That's because I'm using a write mode. So I either overwrite or I create a new file when I use write. So I'm going to take that same basic program right here, and I want to modify it just ever so slightly to do an append operation. Let's create a new file here. And let's call it append. Let's say file, save as, and let's call it append, append.py. And I'm going to change the mode to A. And this should add to the bottom of the file. So in this case, I'm just going to run this again. And instead of overwriting the data, I'm going to add to it. So at the end of the file, I'm going to say, enter some text. It says, my wife is April. And let's see what happens here. I'm going to reload this file. And notice I got a new line here. It says, my wife is April. And if I run it again, I'm going to get a second one, third line. If I said, I have two daughters, not daughters, daughters, like that. And if I reload this, I have a new line there. If I didn't have that \n or that escape character, I would end up with all of the text looking like this, and it would just be on one line. That's because I don't have the line ending in there. But if I want to add that line ending so that everything shows up on a new line, I'll do \n. If I want to add two lines, simply just put in \n, and that will double space it. And then if I go like Blaze is a developer of 30 years and I reload that, and I get a new, notice it put two blank lines in there. If I run this one more time, I'm going to get Blaze writes Python code, and reload this. I've got now a blank line in there, and so I've double spaced it by putting two \n's in there. So you can see there that I'm using line endings to put new lines into my text, and that's something that's going to make your files more readable, as well as telling the application that that's what I want to add a new line. And you can also see that I'm using append mode here so that it's actually appending to the end of the file versus overwriting it when we went with W. Let's go ahead and do a write. Now we've done write and append, let's see if we can read this file back into Tony. Okay, now I'm just going to take this same code that I have here, and I'm going to create a new file. And I'm going to paste it in, and I'm going to call this one read.py. And this big file, I'm going to just read the data. And this would be very easy to do. Instead of opening it as an append or write, I'm going to open it as R. And instead of writing data, I'm just simply going to read the data from the file. So read X, read like that. And I'm going to assign it to a variable, X equals f.read. And I'm going to close the file, and then I'm just going to print X to the screen in that case. And so this is going to read the contents of this file right here and print it back to the screen right there. So let's see what that happens. And notice what it did there. It just took all the code, all the data out of that file that I just wrote, assigned it to a variable, and wrote it back to the screen. So if I go back over into my text editor, and let's just change some of this right here. Let's say I'm a developer. Now, as my wife is April, I have two daughters. Yes. And let's say I'm a developer of 30 years. And let's put a smiley or sad face or happy face at the end of that. And Blaze writes in Python. Let's fix that. So I'm editing this file. I'm going to save it now using a text editor. And then I'm going to simply run my little program again here. And all those changes are now reflected in my file, and I'm simply reading the file right here. So again, reading is really easy to do, but if I was to run this against a file that didn't exist, it's going to say something bad happened. The reason why that happened is because this file does not exist on my file system, and that's why I need to try catch around that. So if it has a problem finding the file, or for some reason it can't read it, or some other reason that would prevent it from reading it, what you end up with is an exception. And so it's going to skip down here to my exception and simply write something bad happened to the screen. So that's why I want to do something like that. But all in all, this is a very easy to follow example that we have here. We have our write, which we're just writing the file. We have our append right here, where we're adding to the bottom of the file. I'm going to clean this up, just add a single line. And then I have my read right there. So congratulations to this week's challenge participants. We have Madison B, Samuel G, and Jacob G, and Judson S. All of you successfully completed the challenge, so thanks for your entries, and I look forward to seeing this week's entries. Okay, for this week's challenge, it's pretty straightforward. I want you to write a diary app. So basically what I want you to do in this program is have a program that will read a file and will display the contents of that file. That's basically the journal that you're going to be maintaining with this little app. So it's a journal app or log or whatever you want to call it, and it's going to be storing the data in a text file. And so when you start the program, display the contents of your journal that is stored in a text file. Then I want you to ask the user to input a new entry into that. So basically get some keyboard input from the user and then append that to the bottom of the file and then exit the program. And so this is a fairly straightforward program. We've seen examples on how to do this already, but there's a few things you'll have to contend with, such as whenever I start the program, what if the file doesn't exist? What am I going to do to handle that? How am I going to handle that? So I want you to think about what we've learned and think about how you might handle creating a new file if the file doesn't exist. And then from there, I want you to be able to detect whenever the file does exist, display the content of that file. And if it, regardless of whether it exists or not, be able to append data to that file with new entries with the keyboard that is going to be the user input into the particular file that we're working with. So all in all, it's fairly straightforward. You can check out all the code samples for this week's lessons at the URL here on GitHub, github.com/theonemule-ce2c, and then you can use those examples as a way to get started. But I want you to think about how to handle those scenarios that I just talked about in this challenge, which is really going to be the meat and potatoes of this, because it'll kind of get you thinking about how I can handle file IO with the try-catch exceptions. And there's other ways if you want to use those that we didn't talk about to detect whether a file exists and such as that. All in all, it's going to be a fun challenge, I think, and it'll be a nice little fun app that you can play with whenever you're working through the challenge. So here's my example. I've obfuscated. You can see that I'm printing something right there, but otherwise I'm going to run it. Notice what it says here. It says it prints something to the screen, my diary. It says my diary does not exist. And so what it's doing is it's doing something behind the scenes to handle the case where the file doesn't exist, using some exception handling. And once I have that, I'm going to say, Blaze, this was a fun lesson. And it's going to append that to my diary. So if I run this again, instead of printing out this diary does not exist, it's going to print out the contents of that file. And I'm going to add a new entry. So it says, what's on my mind? I am pretty stoked about Python. And run that. And let's run it one more time. And we should see that new entry into my diary again. So you can see here that I'm adding a new line to each time I run the program. So this is my example of the application running, and I want you to do something similar to this with your code. So good luck trying to figure this out. It's not that hard, but if you need help, please feel free to reach out to me. I'll be glad to give you some assistance. So looking forward to your submissions, and good luck. If you like this content, please consider liking this video, then clicking on the subscribe button to subscribe to our channel, then clicking on the bell notification icon and selecting all so that you'll get notifications when new content becomes available on our channel. You can also click on the share icon and share this video to any of your social media platforms. Sharing this helps make it more widely available for those who might be interested in coding. Also, consider following us on Twitter so you can see updates on Twitter whenever new content becomes available, as well as other announcements related to Cool Enough to Code. You can also help us out by becoming a patron on our page by going to our Patreon page at patreon.com/coolenoughToCode and then clicking on Become a Patron. And there you can find out more information about how you can support our work with Cool Enough to Code. And like always, you can check us out online at coolenoughToCode.com. There you can find a schedule of all of the upcoming lessons that we have. You can also find out more information and reach out to us online here. And you can also watch the live stream as it comes out each week on coolenoughToCode.com as well. And like always, thanks for watching this lesson on Cool Enough to Code.